So thank you for coming to this talk. Obviously, it's actually a talk that I've given a bunch of times at different places. It's a little bit longer because it's going to contain demos and things. And I did reword the title, specifically thinking about this event. So patterns and practice for building enterprise-scale HTML5 apps. I'm guessing that's obviously something that who works in what they would class as the enterprise? Okay, quite a few people, lots of ups and downs. Yeah. So because this isn't working, there we go. Because it's 90 minutes, I'm going to break the agenda down a little bit, and I know it's the last talk of the day as well. So I'll give the talk and I'll give demos of a tool that emphasizes the concepts, the patterns and practices. I'm happy to accept questions any time, again, because it's 90 minutes long and it shouldn't really break the flow of it. But do be aware that the way that the talk's structured is that I'm going to introduce things and then it'll make you go, well, how do you do that? And then the point of the next section will be to tell you how you do the thing that you're hopefully thinking about. So don't be scared to ask questions, but please don't feel bad if I say, oh, I'm going to answer that next. We'll have a chance for Q&A, and then at the end, there's a chance for practical. I don't know exactly how long I'll go, but if there's 20 minutes left at the end, I've got a whole bunch of 8 gig USB drives, which are worth it in itself, that has a tool, a Blade Runner JS tool, that's the thing I'm going to talk about, on it, so we can sit down and you can try it out and go through some of the things that I'm going to show. The Blade Runner JS guys are here. They've also got some really nice T-shirts that they're hiding behind their desk. American Apparel 50/50. I like my T-shirts, so I would definitely go and speak to them and get some T-shirts. So I don't work for Blade Runner JS, which is Kaplan Systems. I work for a company called Pusher. I've got a silly job title. And Pusher is a hosted service that makes it easy to integrate real-time functionality into web, mobile, IoT apps using whatever technology stack that you're comfortable with. So whether it's .NET, Java, Node, Ruby, PHP, we offer 2 simple integration points, WebSocket for persistent connections and real-time data, and an HTTP endpoint for publishing messages. So that's a little bit about me. I'm a chief evangelist there, or head of developer relations, or whatever you want to call it today. But this isn't about that. It's not specifically about Blade Runner JS, although I'm going to use that to hopefully emphasize these concepts. It's really about these patterns and practices that fed into workflows and application architecture that's supported by this Blade Runner JS toolkit. And I'll show you I'll give you a bit of background about what it helps Kaplan Systems build. Now, I used to work for Kaplan Systems, and I have done so in 2001, in 2005 maybe, in 2011, and then 2000. I've been and gone a bunch of times. They do a lot of really cool technology. It's financial focused. So what they actually do is they help customers build web trading platforms. So from back-end integration into the sources of data, through delivery of that data, and very specifically around building these front-end trading applications. In 2001, I joined Kaplan as a software engineer using JavaScript to build SDKs to build these sorts of applications. So this is 2001. I remember when in my job interview, they showed me this thing called WebSheet, and I was blown away the fact that this was running in the browser. There was real-time data streaming into it. I'd done some dynamic menus when I was at uni. I hadn't done any of this kind of real-time interactive application development that Kaplan were doing. So the focus of this talk is about how Kaplan build that and the patterns and practices that go into that. I'm undoubtedly going to drop into we, because I'll be thinking about when I was doing it, but hopefully that kind of adds to the story. The focus will really be about HTML5 development, although there are native mobile SDKs supported. So Kaplan, as I said, have been doing this for a long time. And around 4 years ago, they got to a point where they were basically in a world of pain. They had a large JavaScript-based application with loads of assets, and it was becoming very difficult to manage and maintain and move forward and progress. So they kind of reverse engineered, looked at all the problems they were having, and then came up with a set of patterns and practices and workflows that would help them avoid those problems, and then they create some tooling around that to make sure that those things were adhered to during the development process. So that is BladeRunner.js, and that's the guys, as I said, I don't work for them anymore. I did rejoin a while ago and help them open source it, which is my contribution to it. I still contribute occasionally. It's an open source developer toolkit under lesser GPL license that I think I've even got a WYSI thing that comes in. Open source, so anybody can use it. It's been really interesting, the process of open sourcing it, and it's a whole talk in itself. But specifically, we identified that it was most useful to enterprise scale application development because you don't start to see the benefits of doing things in certain ways until you go large, until you have multiple people contributing, until you've got a large code base. So I'll cover all that sort of thing and say why this toolkit was useful. So please go and say hi to the guys and get a t-shirt and so on. So I want to answer what a large-scale JavaScript app is. Now, because this is, again, an incarnation of this talk based on a different audience, I'd be interested, who's heard of Adi Osmani? Okay, a few people. Cool. Okay. So there's a guy called Adi Osmani who works on the Google Chrome dev team, more of kind of an evangelist advocate role. And a while ago, I think he worked at Yahoo or AOL. It might have been AOL. And he wrote patterns for large-scale JavaScript application architecture. And this is quite a while ago. And he defined a large-scale app as, in my view, large-scale JavaScript apps are non-trivial applications requiring significant developer effort to maintain. So obviously, I've already mentioned maintenance as a problem. So they're going to require a lot of maintenance. And that there's the most of heavy lifting and data manipulation display falls to the browser. So we're pushing more and more to the browser. Data manipulation and display, and obviously business logic as well, the sort of stuff that's executing can be classed as business logic too. Specifically, you've got a highly functional application. I don't know how good the developers we are, and I know it's great to create succinct code and very elegant code, but the more features you add to an application, the larger your code base is going to be. There's no getting away from that. So you're going to have a very large code base. Kaplan Trader is actually an SDK that applications are then built on top of. So specific apps are built on top of. And the SDK itself, this was taken probably a year ago, this snapshot of data, like 1,000 JavaScript files, 131,000 lines of code. You can work out that that's 131 files, 650 test files, 95,000 lines of test code. You probably should see more of this. So that's a large JavaScript app. And then that's the SDK, and on top of that you build the applications, which is 50,000 lines of code, 21,000 lines of test code. So is anybody here building like a JavaScript single-page application with that kind of code base? Yeah? So they exist. That's the validation. And that's just JavaScript. So on top of that, there's HTML templates, there's CSS, there's images, there's ITN for multi-language support, there's config, there's any other assets that go into that code base. The application is going to be complex. So in order to achieve the kind of functionality you want, there's going to be a lot of complex interaction going on there. So a good reference point, who uses Gmail? Okay, lots of people, or Outlook.com. Anyone use Outlook web? Okay, a few people as well. So those applications are, relatively complex single-page applications that let you do loads of things from, it's not a great image with this light, but, from search, through paging through your emails, through filtering them by label, through their, in this case, specific filtering that Google have provided. And I particularly like this compose view because it does lots of stuff in one single feature. You can search your contacts, you can compose a rich email, you can attach things from your desktop or attach things from Google Drive. So there's lots of complex stuff in that. Does anybody disagree that that's not a good example of a complex app? It's not the most complex, but it's pretty complex, and it's kind of a reference point. I think this is Kaplan Trader 2, and I think on stand the guys are showing a slightly newer version of this, but it looks pretty similar. So this is just an example, again, to demonstrate the sort of complex application functionality we're talking about. So executing trades, there was dragging around of this layout. There's charts, there's real-time news, although you can't see the content of that, so that's classed as ideas to feed into trading. There's this, I don't really know what that is. There's grids, and this is really interesting because there's lots of data, lots of updating data, not in this example, but You obviously don't want all the data in the UI, so there's a lot of scrolling and requesting data, complex interactions with backends, interaction between the different features in the app. And there's TV and all sorts of things integrated into this. So it's a pretty good example of a complex single-page application. So they're both these large single-page apps. They're offering complex functionality. So not only the things that you can do with them as a user are complex, and the interactions that a user performs with that application are complex, but also the interaction between components, in the browser is relatively complex, whether you think about them as components or pieces of the system. And there's also complex interaction between the client and the server. So anytime, for instance, you scroll, there's interactions with a back-end server. There's probably multiple web APIs that it's communicating with. There's various forms of persistence. There's real-time streaming data. There's all sorts of stuff. So users and technology. And in this example, and also with things like Gmail and Outlook, you keep these apps open all day. Now, I think that obviously these patterns and practices, workflows, and so on, have come out of building like a web trading front end. So the sort of application that you would leave open all day, that is a single-page application. It's not a multi-paged app that you navigate through. But I do think that a lot of these concepts should be relevant if you're creating kind of rich front-end applications. These apps are around for quite a long time, so features will change. You're building a product. The whole point in building a product is that you'll identify change, add new features, and you should be able to do that without it breaking your whole application. You'll identify features that don't work, and you'll remove them. Keeping with the Gmail theme, this is an idea of the chat Gtalk through to Hangouts. The way that things change, kind of an emphasis on like where's the video? Oh, video and more down here. We've started to see it emphasized a bit more, and now Hangouts is basically screaming at you to jump into a video call. And the point is that you should be able to make these changes in isolation, if possible, without breaking the whole application. Something that's often not thought about, and one of the things that actually, as we open sourced this and thought about what we were doing, that became very relevant, is that the human factor is something that is highly important at scale, because you've got multiple contributors. It can't be maintained by a single person, even if you lock them in the basement, and they're really good at coding, they can't build it themselves. So you've got multiple contributors. So front-end devs, back-end devs may not directly contribute to that code base, but they will be building schemas or exposing APIs that are interacted with via the front-end code base. Designers providing assets or CSS, or maybe making some changes to the code base, depending on how your organization is structured. QA, so at Kaplan, they have a QA team that do write tests and contribute to that code base. There might be some config and so on in there around infrastructure and release engineering, and technical authors. If there's text-heavy content in there, you'll need them to be able to make changes and so on. So how do you build a maintainable application that has that massive code base? What's the architecture to support all those different things? A large code base, multiple contributors, a code base that's around for a long time that supports change. How do you make sure that all these different types of people, different skill sets, can contribute to this code base in a harmonious way? How do you ultimately emphasize quality? And that was one of the big driving factors behind this. It was to make sure that the product could be tested and therefore was of high quality, because you don't want to be executing trades, clicking on $2 and executing for $1 million, which is pretty obvious. That might have happened in testing, but never in production. You need a productive developer experience. There's a lot of a big push at the minute towards developer tooling. For those who do .NET, I've done .NET a bunch of times. I always thought the Visual Studio was an amazingly productive experience, that it provided everything that you needed out of the box to start developing. So that's really important. So that one of the Blade Runner JS taglines is your first line of code is feature code. So how do you make sure that the first thing that a developer is doing is actually starting to add value to that application? And all these things need to be complementary. So whatever we do, however we solve these problems, let's make sure that they complement each other. I can't really go through that piecemeal, what the solution is. So again, this is pulling from the current trending JavaScript node world. But you can take this quote and look at any textbook over the past, I don't know, 20 years probably, and see a similar quote saying that a good solution, a good way of architecting and building applications is to write small, focused, modular parts and progressively combine them into bigger things to make your app. I'm sure we all try and build individual pieces of functionality and plug them together. So how do you specifically do that? With this clicker, and it works. So the solutions that, well, the patterns and practices, the solutions, the way that these applications were built were through some sort of component widget, I hate the word widget, or modules. I think a much better word is feature. If you think about your application being made out of features, and you can develop your features, it's a much better way of looking at it. A services layer, so who uses Angular? Okay, a few people. So you'll be aware of the idea of services, some sort of MV star. Again, I don't think there's anything particularly surprising here. I'll talk about the specific MV star solution that Kaplan went for. Efficient testing, and I don't just mean, oh, it runs quickly. I mean that the results of those tests are reliable, and that doesn't always happen. I'll go into that. And tools support this workflow. I'm going to have to just press space, I think. So, okay, time to prove it. So let's start with very basic. Oh, anyone got any questions at that point? Does that make sense where I'm going with this? Yeah? Okay. So this is, I'm awesome at design, as you can tell. So this is my very high level kind of like application stack. We've got some backend services, we've got the network, probably the internet or an intranet. And in the browser, we've got our application code base, and we've got the document object model. So I mentioned it's nice to think about building features. So the first thing that we do is we break our application into feature. So you can think of them vertical slices of functionality. Now, if you take a look at something like Gmail, you could do something like this. You know, you could look at the search bar as a piece of functionality, these set of labels, this large pane of your emails that you can scroll through, maybe this tabbed section, maybe this little drop-down widget at the top, specifically with admin stuff. Again, I like this compose view because it's a nice, rich feature that you can kind of think about on its own, that interacts with loads of different things. It's got lots of functionality in there. So the problems that solves are, this will make the development managers happy, because when you're splitting your application up in this way, you can have each of your teams or your individual developers each working on a feature in isolation. So they're not reliant on each other. They're not all running in they're not trying to run the full application and having all the code together. They can just build a feature in isolation. So it's good use of a resource. I'm a developer, so I don't like being thought of as a resource, but I can see from the manager's point of view that it makes a lot of sense that everybody's just getting started and writing code. With web apps, we quite frequently see this. You can't see that. That's an error log. And this is obviously the app pretty broken. So it could be that someone's made a change for this component down here, and I'm building this larger component here. What's this? Trade tiles? But because someone's broken this down here, I can't do any development here. And that happens quite a lot. Now, obviously, we've got source control. We can roll back. We can say, right, there's a break there. I'm going to go back. I don't want that change because, obviously, it broke everything. But that still happens. Even with continuous integration systems, sometimes these things get through. Another one, which is rather silly, but actually, if I explain it, I think it makes sense. So say I'm the developer building this sort of chat functionality that you can't see particularly well down here. But I'm specifically tasked. I work at Google, never, and I'm building this piece of functionality. So I make a change. I refresh my browser. 1, 2, 3, 4, 5, 6, 7, 8, let's say 10 seconds. I was counting really slow there. So that's, every time I make a change, I need to wait 10 seconds to see my change reflected. Now, I'm pretty bad at getting distracted. I'll be in TweetDeck or I'll be off making a coffee. So every time I make a change that I want to see reflected in the UI, I need to wait for the whole application to load, even though we saw all the other assets came around. There's a lot of stuff at the minute around making sure that above the fold loads first and so on, and all this stuff isn't just relevant to the users of your application. During the development lifecycle, it's a complete pain to have to wait for this whole application to build to see the one small change that you've made. If you've got a large code base, it can be pretty hard to find the assets. Now, obviously, it's again yet another simple and obvious thing to highlight, but again, it is a problem. How do you structure this code base to make sure I can find the CSS for a specific button, or where is that located in my code base? Where's the JavaScript click handler for this particular feature? So to go into the solution for that, and I think we're starting to see this with how people are structuring code bases and with some progressions in web technology, is that instead of having an assets directory at the top of your application, with all your JavaScript under one folder and all your config under another, all your CSS, we instead split our application by feature, which is what I've spoken about already, is that we have all the images, CSS, HTML, JavaScript, config, ITN, whatever it is we're doing with our feature, and tests located under a single folder, grouped together, high cohesion, functional cohesion. So if we know that for this FX tile, obviously there's multiple instances of this, but for this FX tile, if we know that all the assets are located on disk together, it lets us do some nice stuff, such as ignore these side panels. I'll go into those in a bit. Such as running our feature in isolation. Now, who here has started a new piece of functionality, and you start in a little side project, and you build a little bit of code, you run it in a nice little web page all on its own, and eventually then you go, I need to put this in the app. And then you ditch your test harness, whatever you call it, put it in the application, and then every time you want to develop it from now on, you need to reload the whole application. The thing is, we've kind of gone, well, actually, that little test harness, that workbench, Kaplan, they've said that this is a really nice piece of workflow. It means you're not affected by changes elsewhere. It means you can focus on building your little feature. It means that your code needs to be, your application architecture needs to be structured in a way that you don't rely on all these other things. There's loads of other benefits too. So you're not affected by code changes elsewhere unless it's shared code. Now, there's no really getting away from that. There are things around versioning libraries and so on. Because we know all the code for that feature is under a certain folder, we know exactly where the CSS is, the JavaScript, the tests, and so on. You've seen that it can be run in isolation. You obviously need tooling to support that, and an understanding of the structure of your app and these features. And you get fast reload times because you're not loading all the assets for your app, you're just loading the assets for that single feature. So I just want to provide a little demo. It's not a particularly exciting demo, sorry. Yeah? So, okay, so the question is, what do you do when you do have a shared library amongst multiple features, say? So Kaplan haven't specifically solved that. They're looking into what the best package management solution, how they deal with versioning. There's a tool called Browserify that people might have heard of that means you write code in a common JS style, kind of like Node. And I believe it also deals with different version dependencies. It will create closures and include these libraries in certain closures, and then different features can access a specific version of libraries. So I think there are solutions out there, but ideally, for size, you would want to just have one version that everything could rely on. So, good question. Right, I'm going to see that. Okay. I'll quit that for now. So all I wanted to do is just show some of that stuff that I'd shown there. So this is the toolkit, Blade Runner JS, a bunch of stuff in here. There's an SDK folder. I'll go into the SDK. And what I'm going to do, I'm going to execute the brjs command. Everyone see that okay? I'll make it a bit bigger. Oh, not turn the sound on. Right, okay. Create app. Out of interest, who's used something like Yeoman or Gulp or Grunt? Okay, a few people. Cool. DevWeek. And then I'm going to create a blade. So Kaplan call their features blades. I'd go and speak to them about that. The idea was that it was a vertical slice of functionality, and that kind of works quite well. But there's some interesting things around when something's a blade and belongs to just a single application, and when something should be shifted to a library and becomes more of a component that's shared across multiple apps. So I think it's yeah, go speak to them. create blade DevWeek. Now, ignore this default. So blades can be, again, structured into blade sets to group similar features together and share code. But default allows you to put all the same, to have like a top level set of just blades. I'll show you the directory structure shortly. I'll call it input. And then I'll open up apps. So, I know this doesn't show particularly well. So there's an apps folder using this tool, and in DevWeek we get this basic application scaffolded, and also the blade that we created. So here I've got an input blade. I just called it input because the example that I'll show later is more like a chat application. Now everything related to this blade is under this folder. So I've got resources, so HTML templates. If we're going to do multi-language support, we've got all of XML, so you need a folder for that. We've got a source, which is the JavaScript. We've got acceptance tests. We've got unit tests. We've got themes with an example of potentially multiple themes. And the workbench. Now, the workbench is that tool that lets you run that feature in isolation. So what else was I going to show? Great blade. Right, OK. And then if I run the tool, so this runs the web server for it. And one of the interesting things about this is that it does a bunch of stuff that, again, the trend with tooling is very much to go to the command line and to understand exactly what the command line does. Now, Blade Runner.js has this web dashboard that lets you do common things in a kind of nice UI way. So I could create an application in here. I can click and look at my DevWeek app, and I can run my input blade in isolation. Again, I'll talk about these two side panels in a bit. I can look at the code for this. Input source. So this is input view model. So I'm kind of obviously exposing a view model already, but we'll go into that a little bit. I can change, I can say yo DevWeek and reload my app. And we see yo DevWeek. It's not particularly exciting, I appreciate, but and I can go into my I18N, which is supported by this, and I can say this is the en.properties. Say yo from, and then the tool deals with building that and making sure that this text is changed. So we can see running that feature in isolation. I think that was okay. The next thing I wanted to show was a larger application. So on this USB drive as well, there's this modular app. There's actually a workshop that's been created for this. But just as an example of a larger app, there's something that's been broken into a header, an input, a login, messages, and a user card. So these are these different blades, again with their own source, their own tests, their own themes, and so on. OK, cool. Any questions about that at all? Pretty simple? Great. OK, so that was just creating a feature, and that's the very basic workflow. But that's from starting an app to starting to write feature code, which would hopefully be more exciting than changing some text in files. But straight away, I can make changes, write JavaScript, refresh, see what's happening. I can also execute tests and things, but I'll show that as part of the tooling part. So now we've got these blades. We need a way of composing them into an actual application. So this is an example. So Kaplan decided to call this idea aspects, so views into your application. So you would create all these different blades, all these different features, and then you'd want to compose each of these different features into an application. So it could be that you do some sort of browser sniffing when you serve up your application and you identify there's a desktop, a tablet, or a mobile. Or it could be that you've got some sort of login and you identify that a user has permissions to see all these extra features. But this is an example using the browser sniffing example. So it could be there's like a rich, so if this is Gmail again, if there's a rich email compose feature, really that's only suitable for the desktop. Processing power, screen real estate, and so on. But you might want to still use the same search feature across these multiple aspects. So you include it in the desktop, the tablet, and the mobile. So each of these has their own entry point into the application, an index.html, and you just simply include them. So the demo here is really simple. So if I look at the DevWeek, so down here you'll just see in DevWeek I've got an index.html. I go to my browser. I know that the URL is just getting rid of that, and I see this boilerplate code. I can remove this, which is just that boilerplate stuff that appears. I think I've missed that bit. There are these specific tags that the tooling understands, so that includes the IT and bundle, the language definitions. This makes sure that the JavaScript that is used by that aspect is bundled, and you can do things like specify how you want it minified, or whether you want it combined or split out as individual script tags to help during the dev process. So here I'm saying I want devweek/app, and that's actually in source, in app in here. So what I'm going to do, I'm going to just, let me see if I refresh that just now. Okay, so that's gone because I removed the HTML. And I'm just going to copy and paste. I'm not going to try and live code. Not yet, anyway. So if I add that in there, what we're doing is I'm getting this view model object, which is defined in input, source, input view model. And then saying this, Kaplan chose to use knockout, so there's a helper library in there called a knockout component. I'm going to create a new input model, create a component object, get the element that's generated from that, and append it to the body of the document. So if I refresh that now, you'll see that we've got that individual feature that's been, a single instance has been created. Obviously, I can do app.prototype add blade and create a utility function, shift that in there. I can create a bunch of times. So I'm creating multiple instances of that feature. And then obviously you would do, in the aspect itself or in the theme related to the application, you would probably, can you see that? I'll probably, you'd start to build, make the UI, what you would call kind of the layout management. So we're starting to build, it kind of works with these very modular looking front ends, but ultimately with a CSS and with maybe some JavaScript for layout management, you can use this same process. So Kaplan actually used something called web-centric to do their layout management stuff. So they've actually got a separate layout manager that sits at the aspect level, but they build their features in isolation that doesn't have any specific requirements on how it's, how this UI is managed. So I'm pretty sure that was it. Oh yeah, okay, so I was going to also show the other application. So we saw the module app which had a header and so on. If I run that application, I think I'll need to log in. It's kind of logged in. Okay, now this app is built out of a bunch of different blades. So I don't know if this is particularly great, but you can see there's the header, which is a blade in itself. There's a login, which you can't see. There's the chat messages. When I scroll down, there's the input. And then there's this idea of this user card. So that's not a particularly great one. I don't know who that is. So all of these has been built in isolation and then brought into this aspect to build this app. Okay, any questions about that at all? No, pretty simple? Cool, okay. So how do these things communicate with each other? So this is where services come in. Again, those that have used services in something like Angular will know all about that. So services are used to share, basically access shared resources. Because these blades, these features, shouldn't be directly referencing each other, because if you removed one, then the other one would break. So then you need a way for them to either communicate with a backend service or communicate with each other. So that's where these services come in. So intercomponent communication of some sort, persistence, whether that's in local storage or whether that's with some sort of web API, RESTful API, or whether it's a real-time service like Pusher. This example uses something called Firebase. And this is a .NET event, so I'm assuming that everyone's okay with interfaces and contracts and protocols. There's a bit of a trend in some of the web development world that will say some of these ideas, these concepts, aren't relevant when it comes to JavaScript because it's not natively supported. Does anybody use TypeScript? Okay. So you know the benefits of strong types, of contracts, of interfaces, and so on. There's a really good talk by a guy called Mark Trossler who works for Google. He also wrote a book on testable JavaScript. I'd highly recommend you watch that because he talks about all of these things that developers in the enterprise world and developers that have used .NET and Java have taken for granted and understood, almost imposed on them by the language, but have also seen the benefits of, that these things aren't natively supported in JavaScript, but there are still benefits to it. So we've got our application split into feature, so we introduce this services layer. So the benefits of this are, when you've got this very complex application, you're going to have a bunch of dependencies. So in this case, authentication, databases, real-time services, web APIs. And even to get started, you need all of these things with their own runtimes and their configuration set up and running. So I'm pretty sure that people have started a new job and it's taken them a week to get their development environment set up. It's a complete waste of time because you need to install and configure all of these things. But because we can run our features in isolation, we potentially only need the services for that individual feature to be running. So for login, we only need authentication. For, say, a latest news feature, we only need the real-time service. But because we've got this services layer, which is saying anytime that I want to access some sort of back-end service, I want to communicate with other things, we're doing it through this services layer, we can actually make the implementations of these services pure JavaScript. So there's no real need for any back-end components to be running at all. So we're accessing JavaScript implementations of all of the authentication service, like a fake database, a fake real-time service, and fake web APIs. Now this has been really beneficial for Kaplan when they've been building a trading service and a trading application, and they've got a customer who said, yes, we'll have that real-time streaming of those prices available to you in 3 months' time, and you want to build that front-end component now. So what you need to do is you need to sit down with them, agree what that data should look like, agree how the negotiation should take place between the front end and the back end, and build a fake implementation of that. Now, previously, Kaplan used to do that by creating, it was normally a Java data source that would be running. But again, that took quite a lot of time to develop, and also you had the network in there as well, so it made it a little bit more harder for testing. So this has been really, really useful. Kaplan specifically use, and Blade Runner.js supports something called a dynamic service locator. Now there are pros and cons around lots of dependency injection style solutions. This has worked quite well for Kaplan, and it's as simple as some sort of bootstrap of your code, you create a new instance of something, you register it as a string, just as a string name, and then anywhere you want to use it, any feature that wants to actually use it, just go service registry.getService chat.service. There's actually a nicer way of doing this using the require syntax. Oh, there we go. That's cool. Don't know why I did that. But you can use the same require syntax. So you require these classes that you're using anyway, so why not use the require syntax? And you identify it as a service by having this service exclamation mark chat for service. I think require.js does something like this. So I don't really want to, there's not a big demo around this, but I just wanted to show some of the code in the apps that we've got. Ooh. Okay. So in the modular app, it's got a whole bunch of services that it uses. In the input blade, look at the source. We access a chat service and a user service. Now that's defined. The way that this actually works is that obviously we don't know the specific implementation that we're getting here. That's been hidden away from it. That's all we know is that we're getting something that will adhere to a certain contract that we interact with. In our test scenario, which is the workbench, people can see that, we've got an aliases.xml, and we're setting the chat.service, the user.service, and also the http.service. So some things might make an HTTP request to fake objects. So we're controlling what's actually returned when we say, I want a service that provides this. So that helps us in this development scenario. The same goes for, so if I show that in action, modular app, messages. Now, over here, this little widget, this workbench widget that we've created, is actually pretending to be the chat service. And when this messages blade, which I appreciate looks terrible, it isn't styled because it isn't getting some of the styling from the aspect, it's gone to the service registry, get me the chat service. It doesn't know that it's actually got a reference to something that's listening to this. So I can do things like that. And I'm seeing logging that's going on, and I'm getting to build my application without the real chat service needing to be there, without having to go through the login process, and building lots of features there. And I think when you start to build larger applications, and you're going to invest time and money into these features, then you start to see the benefit of putting time and effort into these sorts of things. And in the full application, because we've got this lookup, this definition, I'm sure most people have seen DI frameworks with definition files and so on. In resources here, the difference is that we're saying I'm going to use a real HTTP service, I'm going to use a real Fire chat service and a real user service. So, why are we using services? We're using them so that we're not directly communicating with each feature. We're not really directly communicating with, we're not instantiating implementations, which ties us to that implementation. So we can change those implementations over time, whether that's because we're using a service of some sort, and we decide that that service is no good, but I'm going to start using another service. We don't need to change all our code, just the implementation. I'm sure this is like sucking eggs for some of you. And then we can also inject these different implementations at different times. And I think that we do that anyway, I'm sure, in our testing. But also, it's really useful for things like that workbench scenario where we inject our fake, our testable. But also, and then when we build our application, we use the real implementations. So in this example, when we're building the FX widget, this prices workbench widget is pretending to be a real-time stream of data. So if we know that this behaves in certain ways when we push through values at certain tiers, we can, without needing to implement some sort of data source Java code and push through prices when certain interactions take place, we can just create a little widget that behaves, that understands the contract, understands how it should behave, and this understands the contract and how the service it's using should behave, and we can push through data and start to check visually, as part of the development flow, that our feature is working as expected. We can also do things like monitor the trade state. Again, these specific examples are something that Kaplan obviously do quite a lot, so they've invested a bit of time into creating this nice workflow. This is also delivered to customers who get to use it as well. I've already kind of covered this, that in these different scenarios you can inject the different types, whether it's mocks or whether it's testables. So it could be that you build an implementation of a service that you can control in the workbench scenario, but that same implementation is also really useful in your testing scenario because you can control how it behaves and it helps you execute your tests. And obviously in this full scenario, then the real services are there. So efficient testing. So I'll get to MV Star as part of this because the choice was related to that. So in order to understand that, I want to talk about the development practices. So Kaplan have Well, they've got multiple developer teams working on SDK, customer-focused applications. Customers also have their own development teams. Customers might outsource some of the development to other teams. So continuous integration is an important part of this process, and Kaplan were doing Agile like 10 years ago. Scrum, 2 week iterations, continuous integration and delivery, and a build status and then people have to wear chicken hats if they check in and things break and so on. And the real focus is building this quality style software. So in 2009, there were a bunch of requirements. Like IE6 had to be supported, Firefox, Chrome. There were lots of class-level unit tests, so that the code you've seen already is kind of class-based in JavaScript. And there were a whole bunch of application acceptance tests. And the testing triangle that everyone should have looked something like this. Loads of unit tests, application end-to-end tests, so Selenium-driven tests where the full backend services were running, the browser was running, and we were performing assertions. And then we did have manual tests through testing plans. So who uses Selenium out of interest? Okay, a few people. I feel your pain. Now, it is great. So we spent quite a lot of time and effort building like abstractions so that it was easier to define what these tests should do. And we wrote I think it's fixture code, or specific selectors and locators and asserters that let us, that hid away, again, a lot of the repeated functionality that we were trying to test. We had a whole set of VM infrastructure for the continuous integration environment. So the process was a bit like this. I'd be interested in if anyone's got a similar process. So we had all these VMs. We would, is this? Yeah, it's in sync. Okay, so we wanted to pair up browsers and backends. So we had a whole bunch of sets, one which had browsers on them as assets. I think we used Cruise, which is now something else now. So we'd pair up this front end and this back end. We'd reset the state of the backend services, so there's no residual data left over from anything else that's been done. We'd launch the browser. We'd execute the tests, which would obviously interact with the backend services. We'd record those results, reset the backend services, and actually, instead of refreshing the browser, because we'd also monitor the memory usage of the browser, we'd actually kill it and bring it back up. And then execute the next set of tests, obviously. So there were 1,300 unit tests back then. I do remember looking at the code base for this, and 500 acceptance tests. So not that many acceptance tests, but if you think about that Kaplan Trader complex application, you've got to start the browser and execute some relatively complex functionality in there. And there were 10 pairs of VMs. So that's quite a lot. Quite a lot of time invested in infrastructure. And it used to take 8 hours to execute those tests. So that's a bit of a fail, really. Because I think, hopefully, leading up to that, you're all going, OK, this makes sense, this makes sense. And then you see that figure and you go, right, well, that's just useless. Because all we could do is we could only execute that at night. So every check-in couldn't trigger the full build. It could only trigger this at night. And then at the end of the next day, we'd look at the tests, and during the week, we'd go, OK, well, what were the builds? And then we'd have, I can't remember what it was called. There was like a green line, and depending on the test percentage pass, we kind of went, OK, well, it's over that threshold, so we'll say that that's definitely an improvement. But the point in tests is to go, right, they're either red or green. Like, they either pass or they fail. So it's a complete fail, really. But I think at the time it was relatively... So the interesting thing, I gave a version of this talk at Yahoo, and they're having exactly the same problems. They've just implemented a retry function, which is like, OK, it failed, I'm going to retry it. OK, it failed, I'm going to retry it. It either passes or it fails. So there are a bunch of problems. Resetting backend services, because you've got the front end and the back end, it's technology. It occasionally breaks. Nothing's perfect. So sometimes the backend services took too long to restart. Sometimes a process was hanging around that it wasn't killed properly. Someone's made a change in config. Because there are all these different parts, you saw that diagram with all the backend services and the browser and the network and so on, things can go wrong. So you get problems. When we write tests, we generally try and avoid I/O. I know we do. I don't know whether we call it integration tests, but we do look at when components interact with each other, what happens. But we know that it's generally there where we start to see the problems. If we're just executing things against code, it'll work. If we're starting to do I/O, any form of crossing the boundary between different runtimes, things will break. So we want to avoid that. And the DOM is a big part of that. And obviously with Selenium and WebDriver, you're poking the DOM. You're saying, have you changed yet? And that tended to fail quite a lot. So the first thing is we've got this fake layer of services. So we know we're avoiding any I/O in our tests because we can implement our fake or testables or mocks. We're avoiding any I/O in terms of network. But the rule that we basically came up with, especially when you're running tests cross-browser, Firefox, IE, Safari, then different browsers behave in different ways still, definitely back then. So this was the rule, it was don't touch that DOM. Now, who's heard of React? React.js? Okay, a bunch of people. So again, one of the times I gave this talk was this is validation for me, in case you think I'm speaking nonsense. So Pete Hunt, who's a core contributor to React.js, agreed with me. So like one of the reasons that React.js has been built was testability. It's got a virtual DOM, which is a virtual representation of the document object model. So as part of their testing framework, they can test against this virtual DOM rather than against the real DOM. Now, interestingly enough, if you look at some of their tests, they actually get the node from the real DOM when they do some of the tests. So they're not always sticking to it, but it certainly improves things. And I'll show some stats to prove that. So the solution that Kaplan went for was MVVM. So who uses Knockout? Okay, a few people, cool. So an MVVM solution, there's a view model, which is a logical representation of the view. So if there's an input in the view and at some point you have the state changed to disabled, you'll have a flag in a knockout observable in your view model that you change. So we would actually execute our tests at this level against the view model. And we'd let knockout do what it wanted. The nice thing here as well is you encapsulate functionality that isn't specific to knockout in a domain model, having the view model there. So you've got to think about how do I support that change in the future. So if we've got the majority of our business logic in here, and then we update this view model whenever the views should specifically change, then in the future, we can move to Angular 2. I don't know whether that's the logo for Angular 2. And we've done spikes where instead of using Knockout, we use Angular for some components. We can use React, or hopefully web components can be used. So this was the point I was making with the services and with the view model, is that features can be tested entirely in isolation. We can run our feature in isolation. We can execute, we can make calls on this view model, which will trigger a bunch of business logic to take place, and then services will be interacted with, and we can assert the interactions that took place against that service. We can inject our testable, our fake, into the services layer, get it to behave in a certain way, and then assert the state of the view model. So we're avoiding any I/O and we're avoiding any DOM manipulation. So the change from the test pyramid has been that still have loads of unit tests. There's a lot of blade functional tests. We don't throw Selenium away completely. We're not throwing the baby out the bathwater. We're saying, okay, there's still value in understanding that all these components, when put together, do work, and that the core pieces of functionality still work, but we call them smoke tests, and they take a lot less time to execute. So the proof is in the pudding, is that our server room wasn't really as big as that, but it felt like that. And it took 8 hours to execute those tests, and it now takes 30 minutes. Go and speak to, if Dom's here tomorrow, go and speak to him. He thinks it takes 5 minutes to run on a single machine. So the point here is that if you are building you appreciate the architecture, you appreciate the way that these pieces of functionality shouldn't be interacting with each other, you can actually just test a feature in isolation, check it into continuous integration, and let it do its job. So it might take only 5 minutes to execute all your tests on your individual feature. So that's obviously a massive win in terms of productivity, in terms of understanding what's happening. I've got a blank next slide. I don't know what that's all about. So I speak about that process in more detail. I spoke about that in more detail at Scotland JS last year. So I'll share these slides afterwards if anyone's interested in. I go through some of the same stuff, but in a bit more detail. So finally, how does the tooling and developer workflow fit into that? I think you've seen bits of it. You've probably got an idea of how that sort of stuff works. So the workflow is consistent no matter what application that Kaplan are building or their customers are building. You create your application skeleton, create app. You create a feature, create feature. You write some HTML, CSS, you see that feature running in isolation, or maybe you write your tests first and follow TDD and execute your tests. Again, you can run those in isolation without having to run everything else. When the feature's complete, you might add it to the aspect, write some tests against specifically the aspect, build, deploy, and so on. So where does the tooling fit into all this? How are we doing for time? Could be quite short. So the point in tooling is to really identify the things that we're doing consistently and create something that stops the repetitive nature of it. It means that we're doing things more efficiently and we're doing things that are potentially hard to do. That's one of the things. Scaffolding, development server, builds and bundling, how are these assets created? It's one of the reasons that Grunt and Gulp and Yeoman are so popular, because they're taking away some of the pain. And also executing tests that we've had tools for quite a while. The other thing that tooling does is it introduces, to some extent, we'll not say compliance, we'll say we're embracing constraints. We're saying that if you have this large code base, if it's been around for this amount of time, if your team are working on one piece one week and another piece another week, if you're going to work across organizations, you need to do your things in consistent ways. So you need to put constraints on this. There's no other way of doing it. Now, languages such as Java and .NET enforce that through the language conventions. JavaScript doesn't do that. You can do anything with JavaScript that you want. So there's no wonder that TypeScript is obviously gathering adoption, because it lets us do things that we know work, especially at scale. There's a blog post about this, which is quite interesting. Again, I'll share the slides afterwards. The tooling really needs to have a level of intelligence. If you understand, for instance, the idea of services, the tooling understands services, it understands how you structure your code base, it understands how you structure your code specifically, you can build a lot of advanced features into that. So obviously Visual Studio was a great developer tool, and it was a great developer tool because it knew how you structured your code. So an example of that is the Workbench. It knows that in Workbench scenario, it will get the services that you define in a certain way, and it knows how those assets only from that feature folder should be collected and run. It understands that in the test scenario, only the tests, that the services defined as test services should be bundled. And when you're actually building the application or just running it in dev mode, it only gets the assets that are identified as full application assets. So the way that Blade Runner.js does this, and there's a bunch of other tools around this, something called Asset Graph, and I think things like Browserify and Webpack will do things like this too, is that it understands how the code is structured. So it knows that this requires syntax. It knows that, for instance, in this case, the input view model is a blade. It knows that that blade has CSS associated with it, ITN config, HTML templates. And it will do all that bundling for you. So when you require this, it will build a dependency graph and make sure that the bundle contains the right assets. I'll show a demo of that shortly. And customization. So I said about, you need to support change. That's obviously really important. And by completely tying yourself to a certain way of writing code is obviously a problem. So that's why the tooling that we're seeing at the minute, and tooling forever had this idea of plugins. You need to be able to identify the things that change, both in your application architecture, but also in your tooling, and be able to change those things. So at the minute, Kaplan use .js, but in the future, they might want to move to TypeScript. So there is a specific, I think they call it bundler, JavaScript bundler, but it might be that they can swap that out and say, right, I'm going to use a TypeScript bundler now, or an AppScript, or a Dart script, or Dart. So you need to be able to change these things, like automated commands, builds bundling, test runners, and so on. So a quick demo of the tooling. So the first thing is tests. So obviously we've got BRJS test. And I can do modular app. We can't see it. Oh, right. No, yeah, definitely. Okay. So yeah, BRJS test, and then you can point to any folder, and it will discover the tests that are in there. So I'm going to go blades and input. So I'm going to execute all the tests that reside within that folder. And you can do that at the aspect level, which will be any tests related to that application. So the dependencies worked out, and it will go, okay, well, I'll execute the test for that. The other thing that I wanted to show was the dependency graph. I think I've just got a copy and paste. I mean, there's a whole bunch of tools in there, commands, that, again, if you're interested, you can get a USB stick and have a play. That's not great. OK, I don't think we're going to get it on this screen to be particularly readable. What was I going to do? So I can look at the dependencies based on a specific application, hopefully. Whoa. Right, can we see this? OK, so I'll try and highlight to make it a bit clearer. So we're saying the index.html is that default aspect. It only really includes that app.js. App.js includes this helper, which is knockout component, and all its dependencies can be seen there. It also references an HTML service, which is the templating service. Can I find a better example? OK, we can see that we also include our input view model. And we can say that the input view model has got a dependency on fel, which is a logging library, emitter, which is an event emitter library. It uses the user service. So the tooling understands this. It can use bundling, but also if you can go, well, hang on a minute, how come this definition of this class has been included? You can run this tool and go, OK, well, I can see that it's referencing that. You can do the inverse, and you can say, based on a specific class or file, what's using it. And we can see that the seed file for this is index.html, which is that default aspect, and app.js uses it. Now, I don't know why the workbench isn't being shown here, because I would have thought, and the tests that do it, but that would be worth asking. OK. Oh, hang on. OK, so hopefully I've proven everything. So I think we're are we short on time? OK, so we've got quite a while. I appreciate it's the end of the day. Most people want to go home anyway. But if you'd like to stay and have a play with this, please do. If you're not sure about having a play right now, because you'd rather go and have a beer or a wine or something, then by all means come and get a USB stick. So proven, hopefully. So large code base. That's solved by building things in a componentized way and defining things as services. The complex interactions, again, components. We're avoiding this tightly coupled nature between all of these things, allowing us to change. So again, services, nice separation of concerns between pieces of functionality, grouping things together, high cohesion in terms of our components. Again, we've got all our assets on disk in a certain place. So if a team or an individual is focused on changing a specific feature, they're not going to be hacking around with code that all of a sudden you pull down is going to break. It's going to break the feature that you're building. Those things should be separated. Again, libraries are a problem. The tooling also helps enforce that sort of thing. Components, again, they exist in isolation. They don't rely directly on service implementations or on other components, so you can change them over time. By using something like MVVM, you've also got the separation of concerns from the rendering to the domain logic. So you get a lot of value there. The services are common abstractions. And the tooling really does help that productive developer workflow. Now, obviously, Kaplan are building a very specific web trading front end. Their customers are building the same applications based on the same SDK, very similar front ends. So it's part of their product, and it also benefits them that everybody's doing it in consistent ways, whether they change across teams or whether they go out and work with a customer or whether they're training a customer. But if anybody builds, well, if anybody has a product that's around for a long time, a product that has a large code base, a product that benefits from adhering to these certain mechanisms, then it's worthwhile spending time and effort building that set of tools, whether that's going with something like Blade Runner JS, or whether it's taking some of these ideas or some of the other ideas around some of the node tooling, and building a common set of tools that you use across projects, across teams. And when you really get to that scale, a large code base, multiple teams contributing to it, the code base around for a long time, very complex interactions across different components within your application, that you really start to see the benefits from this sort of thing. And it's really interesting the way that Angular has moved from being plain old JavaScript to TypeScript, because they're starting to understand that people are building highly complex front-end applications, and TypeScript offers a lot of value that you don't directly get when you're just using JavaScript, where it's almost a free-for-all, or you need tooling to support certain conventions. So I wasn't surprised at all when I saw them saying they were moving to TypeScript. And the quality, everything that was done there in terms of MVVM, the way you can test that, services, and the way that the tooling supports that, promotes all of this. And it really was the driving factor that we needed to be able to change, maintain, but also have that, that green-red, where the green meant pass, the red meant fail, and we could really rely on it. So that's the end of the talk. So that's me on Twitter. That's the hashtag, apparently. That's my email at Pusher. I'm still interested in what happens with Blade Runner JS and what people do in terms of building these large, complex apps. I personally think that web components are the future of this sort of development, but it's going to be a while yet until all the browsers support it. So I'm more than happy to stay around for another 25 minutes if people want to have a play with Blade Runner JS, or if you want to go, by all means, head off. And thank you very much for coming. Cheers. The sources of data, through delivery of that data, and very specifically around building these front-end trading applications. In 2001, I joined Kaplan as a software engineer using JavaScript to build SDKs to build these sorts of applications. So this is 2001. I remember when in my job interview they showed me this thing called WebSheet, and I was blown away the fact that this was running in the browser. There was real-time data streaming into it. I'd done some dynamic menus when I was at uni. I hadn't done any of this kind of real-time interactive application development that Kaplan were doing. So the focus of this talk is about how Kaplan built that and the patterns and practices that go into that. I'm undoubtedly going to drop into we, because I'll be thinking about when I was doing it, but hopefully that kind of adds to the story. The focus will really be about HTML5 development, although there are native mobile SDKs supported. So Kaplan, as I said, have been doing this for a long time. And around 4 years ago, they got to a point where they were basically in a world of pain. They had a large JavaScript-based application with loads of assets, and it was becoming very difficult to manage and maintain and move forward and progress. So they kind of reverse engineered, looked at all the problems they were having, and then came up with a set of patterns and practices and workflows that would help them avoid those problems, and then they create some tooling around that to make sure that those things were adhered to during the development process. So that is Blade Runner JS, and that's the guys. As I said, I don't work for them anymore. I did rejoin a while ago and help them open source it, and go through some of the things that I'm going to show. The Blade Runner JS guys are here. They've also got some really nice T-shirts that they're hiding behind the desk. American Apparel 50/50. I like my T-shirts, so I would definitely go and speak to them and get some T-shirts. So I don't work for Blade Runner JS, which is Kaplan Systems. I work for a company called Pusher. I've got a silly job title. And Pusher is a hosted service that makes it easy to integrate real-time functionality into web, mobile, IoT apps using whatever technology stack that you're comfortable with. So whether it's .NET, Java, Node, Ruby, PHP, we offer 2 simple integration points, WebSocket for persistent connections and real-time data, and an HTTP endpoint for publishing messages. So that's a little bit about me. I'm a chief evangelist there, or head of developer relations, or whatever you want to call it today. But this isn't about that. It's not specifically about Blade Runner JS, although I'm going to use that to hopefully emphasize these concepts. It's really about these patterns and practices that fed into workflows and application architecture that's supported by this Blade Runner JS toolkit. and I'll show you I'll give you a bit of background about what it helps Kaplan Systems build. Now, I used to work for Kaplan Systems, and I have done so in 2001, in 2005 maybe, in 2011, and then in 2000. I've been and gone a bunch of times. They do a lot of really cool technology. It's financial focused. So what they actually do is they help customers build web trading platforms. So from backend integration into, specifically, you've got a highly functional application. I don't know how good the developers we are, and I know it's great to create succinct code and very elegant code, but the more features you add to an application, the larger your code base is going to be. There's no getting away from that. So you're going to have a very large code base. Kaplan Trader is actually an SDK that applications are then built on top of. So specific apps are built on top of. And the SDK itself, this was taken probably a year ago, this snapshot of data, like 1,000 JavaScript files, 131,000 lines of code. You can work out that that's 131 files, 650 test files, 95,000 lines of test code. You probably should see more of this. So that's a large JavaScript app. And then that's the SDK. And on top of that, you build the applications, which is 50,000 lines of code, 21,000 lines of test code. So is anybody here building like a JavaScript single-page application with that kind of code base? Yeah? So they exist. That's the validation. And that's just JavaScript. So on top of that, there's HTML templates, there's CSS, there's images, there's ITN for multi-language support, there's config, there's any other assets that go into that code base. The application is going to be complex. So in order to achieve the kind of functionality you want, there's going to be a lot of complex interaction going on there. So a good reference point, who uses Gmail? Okay, lots of people, or Outlook.com. Anyone use Outlook web? Okay, a few people as well. So those applications are, relative to my contribution to it. I still contribute occasionally. It's an open source developer toolkit under lesser GPL license. I think I've even got a WYSI thing that comes in. Open source, so anybody can use it. It's been really interesting, the process of open sourcing it, and it's a whole talk in itself. But specifically, we identified that it was most useful to enterprise scale application development, because you don't start to see the benefits of doing things in certain ways until you go large, until you have multiple people contributing, until you've got a large code base. So I'll cover all that sort of thing and say why this toolkit was useful. So please go and say hi to the guys and get a t-shirt and so on. So I want to answer what a large-scale JavaScript app is. Now, because this is, again, an incarnation of this talk based on a different audience, I'd be interested, who's heard of Adi Osmani? Okay, a few people. Cool. Okay. So there's a guy called Adi Osmani who works on the Google Chrome dev team, more of kind of an evangelist advocate role. And a while ago, I think he worked at Yahoo or AOL. It might have been AOL. And he wrote patterns for large-scale JavaScript application architecture. And this is quite a while ago. And he defined a large-scale app as, in my view, large-scale JavaScript apps are non-trivial applications requiring significant developer effort to maintain. So obviously, I've already mentioned maintenance as a problem. So they're going to require a lot of maintenance. And that there's the most of heavy lifting and data manipulation display falls to the browser. So we're pushing more and more to the browser. Data manipulation and display, and obviously business logic as well, the sort of stuff that's executing can be classed as business logic too. So thank you for coming to this talk. Obviously, it's actually a talk that I've given a bunch of times at different places. It's a little bit longer because it's going to contain demos and things. And I did reword the title, specifically thinking about this event. So patterns and practice for building enterprise-scale HTML5 apps. I'm guessing that's obviously something that who works in what they would class as the enterprise? Okay, quite a few people, lots of ups and downs. Yeah. So because this isn't working, there we go. Because it's 90 minutes, I'm going to break the agenda down a little bit, and I know it's the last talk of the day as well. So I'll give the talk and I'll give demos of a tool that emphasizes the concepts, the patterns and practices. I'm happy to accept questions anytime, again, because it's 90 minutes long and it shouldn't really break the flow of it. But do be aware that the way that the talk's structured is that I'm going to introduce things and then it'll make you go, well, how do you do that? And then the point of the next section will be to tell you how you do the thing that you're hopefully thinking about. So don't be scared to ask questions, but please don't feel bad if I say, oh, I'm going to answer that next. We'll have a chance for Q&A, and then at the end, there's a chance for practical. I don't know exactly how long I'll go, but if there's 20 minutes left at the end, I've got a whole bunch of 8 gig USB drives, which are worth it in itself, that has a tool, a Blade Runner JS tool, that's the thing I'm going to talk about, on it, so we can sit down and you can try it out and